So in lesson 2.7, solving absolute value inequalities. Review. What does absolute value actually mean? If you see absolute value bars around an expression, let's see if we can remember what that told us back in chapter 1. If we had the absolute value of x equals 7, and what did that mean? Absolute value of x equals 7. What does absolute value mean? It doesn't mean multiplication, Rose. Well, you're kind of making it into an inequality right now. I'm just talking about an equation. Back in chapter 1, if we had the absolute value bars around x, and it was set equal to 7, what's it really asking us, Trey?
X is 7.
X is 7, okay. Why can x be 7?
15 bars.
Okay, what do those bars mean?
Absolute value.
And what does absolute value mean?
Is equal to
Distance from
0.
Yeah. Absolute value means distance from 0. So it's really asking us to find the numbers that have that distance from 0. So if we said the absolute value of x equals 7, is 7 the only number that's 7 units from 0? In other words, is x,
No.
is 7 the only solution for that one?
No.
What would the other one be?
Negative 7.
Negative 7. Remember, negative 7 is also 7 units away. So we have to think going both ways from 0. Okay, we have to think going both ways from 0. And we did that with equations back in chapter 1. Okay, well, now we're going to change it into inequalities. And this can be challenging. So you gotta be engaged here, and you gotta try and process through this, okay? You can't be off thinking about something else, doodling, doing anything else, or you're not going to understand this stuff. Absolute value inequalities with, what does this symbol say? What's that symbol say?
Less than.
Is less than. And what does this one say?
Less than or equal to.
Is less than or equal to. Just those two symbols. We know there are other inequality symbols. Today we're just going to talk about when it is less than or it is less than or equal to. So here we have the absolute value of x is less than or equal to 2. Here's what that is really saying. X must have a distance of, Rose, I liked your words before that you were trying to use with equations. What were you saying that time, remember? No more than. Yeah. So it's saying the distance, x has to be from 0, has to be less than or equal to 2. So it can't be any more than that, can it? If it has to be less than 2, it's going to have to be, it can't be more than 2. And if it has to be equal to 2, it can't be more than 2. So what that's really saying is you need to find all the numbers x can be that are no more than 2 units away from 0. Does anybody think they know some of those numbers?
2 and negative 2.
2 and negative 2. Because if we put 2 in here for x, how far is 2 from 0?
2.
2 units. So is 2, that would take care of the equal to part, wouldn't it?
Yeah.
Okay. Because the absolute value of 2 is 2. You just said that. So if there's a negative 2 in there, how far is negative 2 from 0?
2.
2. So again, it meets the equal to part, doesn't it? Can anybody give me any other numbers besides negative 2 and positive 2? 1. How about 1? If we put 1 in there for x, now we would have 1, the absolute value of 1. How far is 1 from 0? 1 unit away. Is that a true statement?
Yes.
Is 1 less than 2?
Yes.
What if we made 1 negative?
So,
What's the absolute value of negative 1?
1.
Positive 1. It's 1 unit from 0. So again, we'd have 1 is less than or equal to 2. That's true. Think you got any other numbers you can give me? How about 3?
No, that's too high.
That's more than 2 units away from 0, isn't it? That's too high. So 0. How about 0? Could we put 0 in there? What's the absolute value of 0?
0.
Oh, okay. Is that a true statement?
Yes.
Yeah. How about 1/2?
Yeah.
How far is 1/2 from 0?
1/2.
1/2. Is that a true statement? Is 1/2 less than or equal to 2?
Yes.
So how many numbers do you think there are that would really be able to be put in here for x? Oh, an infinite number. There's a whole bunch of them that would go in there. There's a whole bunch that could not go in there also, though, right? But there's a whole bunch of them that could. Well, here's the deal with absolute value inequalities. We can't begin to list all of those numbers. We can't begin to list all of the numbers that are no more than 2 units away from 0. So we have to write it as a compound inequality, like we have been doing. When we have a region of numbers that satisfies it, then we have to write it as a compound inequality. So what we're going to say here is that then, therefore, x can be between -2 and +2, and this is an and inequality because it's between 2 numbers. It's between -2 and +2, so we write an and compound inequality. So we can't begin, we just said, we can't begin to state all the numbers that are no more than 2 units away, so we have to state it as a compound inequality like that. Trey?
Are we going to graph this?
We are going to graph when we start solving, okay? So right now we're just kind of exploring what does this really mean. Okay, let's look at this next one where it isn't just an x, it's a 3x. It says the absolute value of 3x is less than or equal to 9. So what that's really saying is that expression 3x must have a
Number?
distance. Remember, absolute value means distance. So if we're going to drop those absolute value bars, we say, okay, well then 3x must have a distance of no more than 9 units from 0. So this is the important part. It can't be any more than 9 units. No more than 9 units. It says is less than or equal to 9. No more than 9 then. It can be 9, but it can't be more than 9. So Trey, what do you think how would we set up a compound inequality to represent that?
Put in the numbers for x, but you have to multiply them by the 3.
Oh, but no, we're not even gonna solve this yet. We're gonna say how could we represent that so we could solve it. So 3x has to be between what and what? What are the numbers that are what are the end numbers that are no more than 9 units from 0? -9 and
No, positive 9.
+9. So the absolute value of 3x is less than or equal to 9. We can say, oh, then that means 3x can be anywhere from -9 to +9. And now we would go about solving it, but we're not going to do that right now. Okay? I just want us to know how to be able to ditch those absolute value bars like we had to do when we were solving absolute value equations. Okay, does anybody have anything they want to still talk about with this that's not making sense quite yet? Okay, so the trickiest part of this will be to understand how to set up the compound inequality correctly and not have the absolute value bars involved anymore. So here are the steps we're going to do to solve once we, when we're solving an absolute value inequality. Get the absolute value part by itself. Do you remember us doing that with equations? If we were solving absolute value equations, before we even dealt with those absolute value bars, we said the absolute value part of the equation had to be by itself. Same thing here. The absolute value part has to be by itself. Then we will set up our and compound inequality, because we're only working with those kind today, is less than or equal to. And then we'll finish solving it if it isn't just x in the middle. So in other words, up here, in this one, we would have been finished because it's just x in the middle. We would have had our solution right away. But in this one, We wouldn't have been finished yet, would we? What would we have had to do? Divide every region by 3. Yeah, okay, so let's do some practice of this. Number 1. Remember, you're always the first thing you're going to look at is the absolute value expression part, that part of the inequality is it by itself. So we have the absolute value of 5x is less than or equal to 15. Is the absolute value part by itself?
No.
Yes.
Yeah, there's nothing being added to it outside of it, is there? Or being subtracted? No. It's already by itself, so we don't have to worry about that. Now we say, okay, well now we have to set up our compound inequality where we drop the absolute value bars. So anybody think they know what our compound inequality could look like for this one? It can't be any more than 15 units away. So between what two numbers would it be, first of all?
Negative 15 and positive 15.
Negative 15 and positive 15. Anybody think they can finish our compound inequality for us? Girls?
Then it's less than 5.
Okay, so negative 15 is less than, the equal to bar is in it, so we keep the equal to bar with it. What goes in the middle?
5x.
5x, whatever's inside the absolute value bars, and then is less than or equal to positive 15. So we put it between the two numbers that are that many units away, 15 units away. No absolute value bars anymore, right? Once we set up our compound inequality, the absolute value bars are gone. Now we can solve it. Now we can say, okay, what do I have to do to every region?
Divide by 5.
Divide by 5. So negative 15 is going to be, and don't shortcut this and start dividing. Rewrite it. Negative 15 divided by 5 is less than or equal to 5x divided by 5 is less than or equal to 15 divided by 5. In your notes, you should be able to clearly see what did we do. First thing we did is set up our compound inequality. Next thing we're doing is getting x alone in the middle by dividing by 5. And that we accomplished. And now we say, okay, what's negative 15 divided by 5?
Negative 3.
Negative 3. And what is positive 15 divided by 5?
Positive 3.
Positive 3. X is by itself. We have our solution. We can circle that and say there's our compound inequality solution. That shows all the things x can be, and now our graph will give us a picture of it. So we need the endpoints negative 3 and positive 3. Shaded in circles at those or not shaded?
Yes, shaded.
Shaded in. By the way, today, when you're working with absolute value inequalities, both points are going to have the same behavior. Either they'll both be shaded in or they both will be left open. And then what are the numbers that are between negative 3 and positive 3?
Negative 2.
All these guys, yeah, in the middle, right? Okay. So any number from that shaded region, we would substitute back into our original absolute value inequality would make it true. Anything outside of that shaded region would make it false. So questions? Okay, first step, give the absolute value thing by itself if it's not. Do we need to do that?
Yes.
Yeah. 7 is outside those absolute value bars on the same side, so what do we have to do?
Add 7.
Add 7 to both sides to get that out of there. So now we have the absolute value of x is less than
10.
10. Okay. Now we're ready to do the next step, which is set up the compound inequality. This says x can't be any more, it has to be less than 10 units away from 0. It has to be less than 10 units away from 0. So what are we going to do? Negative 10 is less than x is
Less than 10.
less than positive 10. Notice there was no equal to bar this time, wasn't there? We need to put it between the two numbers that are 10 units away, but they're not included actually. Okay, do we have a solving step to do? No, x is already by itself. Is that our solution then? Yeah, there's our solution. So we say, okay, our solution is this, and we graph it. So -10, +10. Shade our circles in?
No.
No, they're not included. But all the numbers in between are. All of those would make that absolute value inequality true. Questions? Any part of this not make sense on either of these two before we move on? Okay, then let's go to the back side. And let's take a look at this first one, number 3. What are we going to do?
Subtract 4.
We got to subtract 4. We got to get the absolute value part by itself. And so we have the absolute value of 2x is less than or equal to 10. 14 take away 4. Yeah. Okay. What's our next step? No.
No, we have to write it out. Inequality.
Yeah, we got to set up our compound inequality. So what's that going to look like?
It has to be between 10 and -10.
So it's going to be between -10 and +10, and is less than or equal to between both of them.
2x.
Now you're ready to solve it.
No, we're not.
What do we do next?
Now we have to divide by 2.
Divide every region by 2. So -10 gets divided by 2. Take time to write this out. Don't just stick some fraction bars under that last line. -10 gets divided by 2. 2x gets divided by 2. And 10 gets divided by 2. And our solution is, what's -10 divided by 2?
-5.
-5 is less than or equal to
X.
x is less than or equal to
5.
+5. Okay. And we graph it. Open or close circles?
Close.
Closed. Our equal to bar is there this time, so the 5 and the -5 are included. And all the numbers in between, right? Okay, now let me give you a quick caution. Some of you are going to be like, oh, I don't even need to show quite this much work because every time, look what happens. I have a number and its opposite at the other end. You think that's going to happen all the time?
No.
Be careful, it's not. So don't get lazy and don't even divide this out or whatever you need to do. Don't get lazy and say, well, it's got to be the opposite of -5. It's going to be +5. Because that's not going to always be true. In fact, I think in the next one we will find that out. Okay? So what are we going to do first in number 4?
Add 1.
Add 1. In other words, we got to get the absolute value inequality part by itself. So the absolute value is still there. All we've done is get it alone. So what would be our next step now? Negative. So set up our compound inequality. Yeah, so -10 is less than x plus 6. This is when we get to ditch our absolute value bars. Is less than +10. So we put what's inside the absolute value bars gets put between the two numbers that have that absolute value of 10. Okay, now, is that our solution?
No. X is not by itself.
We haven't got x by itself, so what do we have to do now?
Subtraction.
Subtract 6 from all 3 regions. Okay, so what's -10? Take away 6. -16. X is now by itself. What's 10 take away 6? +16?
4.
It's 4, isn't it? So this would be one of those times that if you just didn't even take the time to process and say 10 take away 6, you just automatically put a 16 there, there'd be a problem, wouldn't there? So we have to be really careful. We get really tempted. Our brain tricks us and says, oh, this keeps happening, so just go with it. But it doesn't always happen. Okay, and now we're ready to graph our solution. And are negative 16 and 4 are included? Yes or no?
No.
No, because there's no equal to bar there, is there? And shade in between. Okay, I'm trying to do like something of everything you should possibly, come across in your homework. So anybody have any questions about this one? Anywhere along the way? You're not sure why we did what we did? Okay. Then let's go on to number 5. Number 5. What's our first move going to be in this one? I know what you're going to be tempted to do.
I was gonna do just add 4.
You're tempted to add 4, aren't you?
You have to do the.
But is that 4 outside the absolute value bars?
No.
No, it's inside. Is there anything outside the absolute value bars? No. So we can go straight to the next step, which is set up the compound inequality. What two numbers do we need to set our 2x
Negative-
minus 4 between?
Negative 10 and positive 10.
Yeah, positive 10 and negative 10. We get to go right to setting up our compound inequality. And trust me, you're going to be tempted to add 4 and not do this. And you're going to be like, well, I got the same answer. Well, sometimes you might luck out and get the same answer. You're right, but you will have the wrong word.
Divide by 2.
So what would be our next move? No, I don't think we should divide. We should, now let's add that 4. Now we can add 4 to every region. And negative 10 plus 4? Negative 6. What's left in the middle? Not
2x.
Yeah, 2x. It's still 2x, isn't it? And 10 plus 4? Again, don't let your brain say, oh, just put a 6 there. What is it?
14.
It's 14. Okay, and now our next move is
Divide by 2.
divide every region by 2. So our solution is negative 6 divided by 2. Negative 3. 2x divided by 2 will just be x. And 14 divided by 2?
7.
7. So x can be any number between negative 3 and 7, including those two. Any of those numbers would make that inequality we started with true, that absolute value inequality. So again, don't take shortcuts you really can't take, okay? Okay, 1 to go. What should we do?
Minus 1.
Subtract 1 from both sides. Why?
Because it's outside.
Because it's outside of the absolute value bars. So we get that 1 moved out of there first. Are the absolute value bars still there?
Yes.
Yes, they are. We have not done anything to get rid of those yet. We have just gotten the absolute value part by itself. That's all we were doing. Now what?
Then I do it 5 and then between 5 and negative 5.
Yeah, now we're ready to set up our compound inequality. Whoops, there's not an equal to bar there. This is just an is less than. So x plus 5, what's inside the absolute value bars? Its distance can be between the two numbers that have a distance of 5, and that's negative 5 and positive 5. And what's our next move?
Subtract 5.
No.
Ariel? Subtract 5 from every region. Subtract 5, subtract 5, subtract 5, because we're trying to get x alone, aren't we? Okay, what's negative 5? Take 5 more away.
Negative 10.
Negative 10. Thanks for raising your hand, Trey. We are going to start doing that. Okay, unless I say class. you know, then I'm expecting you guys all to respond, okay? And then what's in the middle? Isaac, thank you.
X.
X. And what's 5? Take away 5. Trey?
0.
0. Can we have 0? Is 0 a number?
Yep.
Is it on the number line?
Yes.
Yeah, it's okay. So there's our solution, our algebraic inequality solution, and now we need to show what the solution set looks like on the number line. Are negative 10 and 0 included?
No.
No, they are not. And we shade all the numbers in between that are included. Okay, I caution you, you cannot shortcut this. You need to follow these steps like, you know, they're going to get you, you know, to the moon. Make sure that you don't try to, you know, say, well, I can just do this and I don't have to worry about that, and drop those absolute value bars, or work with the absolute value, start solving the inequality with the absolute value bars in them. You set up your compound inequality. Once you set up your compound inequality, there better not be any more absolute value bars involved. That's what setting up the compound inequality does. It eliminates those bars for us.